Huh? Today is Tuesday.
Holy macaroni.
So, 7172, if we get to it. We should all have notes. Hopefully they got passed out to everyone. Anyone missing your notes? So they're stapled together. We are hoping to get through 2 lessons today. So, now, know this when I say like we're speeding up, we're getting through multiple things. When we like rush through the lessons and you have multiple homework assignments like stacking up, I will then give you a comp day, like a compensation day, where we can just work on practice stuff in class. Now that doesn't mean don't do your practice outside of class, it just means don't get super stressed out. If you feel like you fall a little behind, we will give you time to get caught up. So, funny enough, and I figured we have to touch on this really quick. Remember when we were talking about the whole earthquake thing with going to California? And I said I would more likely hurt myself in a dumb way than in like, a major way. I got scared by a sea lion and I cut my elbow. But sea lions are really loud. I've never met a sea lion before. So like they were right on the beach, right by where we were staying. And we were down there walking around. And a couple of them looked just like rocks. Like if they weren't sticking out their fins and stuff, they were just like kind of laying there. And there were a bunch of rocks and it was like a cove, if you know what a cove looks like. All of a sudden, it started barking at me, and I got scared because I'm scared of animals that might bite me. So there you go. There's my only injury, and some food poisoning, but we won't go into details about that because I'm vertical now and able to hold down food, so we're just going to move on in life.
What kind of
Tacos, I believe. I had this burrito from this place. So drag, now this says drag, but obviously we're just going to move the numbers and variable to make 3 equivalent expressions, and we want to apply different properties to do so. So first we got to talk about what are the commutative, associative, and distributive properties. So what is the commutative property? What does it mean to commute? The commutative property. Ellie?
A commutative property, I think probably is not going to be correct, but I think it's, isn't it, hold on, it's leaving me, no. It's where you take one number and you can multiply it different ways. Well, not like
maybe. Depends on what like you're thinking in your head. So what's it mean to commute? Monica?
Here's an example. It works with multiplication and addition.
Give me like numerical examples of why.
Like 2 plus 4 is the same thing as 4 plus 2.
Yeah, so addition and multiplication, I can switch it around. So really we're talking about moving. To commute means to move. So if you were struggling to think of that, which I think most of us were, off to the side here, please. Yeah, you might have space over here. You can abbreviate like the COM means to move or order. So the commutative property is when I can move the values or change the order and it doesn't change anything because 2 plus 4 is the same as 4 plus 2. Now the associative property, and this is a really dangerous way to tell 7th graders to remember this. All you need to remember with associative is the parentheses. And why I say this is dangerous to tell 7th graders is because the beginning of that word can help you remember what you're talking about. Because as one of my first years teaching, one of my 7th graders rose their hand without me thinking, pointed out, it looks like a butt. I said, oh, it kind of does. They're like, well, that's how I remember it. Because the first 3 letters, what the associative...
Associate, but it's associate. It's the word
So,
associate to put together with.
So, however you remember it, memory tricks are a good thing because they can help you remember. Here's an example of how this works. If I have 2 plus 3 plus 4, is that any different than 2 plus 3 plus 4?
No.
It's the exact same. Even though I moved what was associated together, I have the same answer when I'm done. The same thing with multiplication. If I had 2 times 3 times 4, or 2 times 3 times 4, it'd be the same thing. So it is all about what you are associating together. Question?
So it works only with addition and multiplication?
We're going to look at that.
Oh, yeah, I have another question.
Yeah.
Can you combine multiplication and addition into a problem?
I mean, yes, you can use both, but then order starts to matter because order of operations. So not necessarily order of how it's written, just order of how you solve it. Jeremiah?
Wouldn't that basically just be the same thing as commutative property?
No, because did I change the order in which these numbers were listed?
No.
No. All I did was change which numbers are associated together. Right now, the 3 and the 4 are associated together. Now, the 2 and the 3 are associated together. We're going to show examples of all of these. Then distributive, we talked a little bit about this last week. That is just when I distribute multiplication to multiple values.
Isn't there still one more property?
Not for what we're doing today. There's a few others. There's like the identity property.
Yeah, that's
So the identity property, and I forget if I put any of these questions in there. Identity property should have actually been part of 6th grade. Identity means it doesn't change. So how do you add and use the identity property? Andrew?
Isn't it just like, plus 0 and then times 1 or something?
Yeah, notice your classmates are raising their hands. How do I multiply and use the identity property, Elena?
Multiply by 1.
Exactly. So whether I multiply by 1 or add 0, it doesn't change anything. So that's your identity property, but we're not worrying about that today. So let's look at a commutative property using some of these values. If I, let's say, anyone have an idea to get me started? Ozzy?
Negative 3 plus 21, and then 21 plus negative 3.
Negative 3
21.
I said negative.
plus, and I'm actually going to use a couple of these parentheses then. Now this does not have to do with associative. That's just to clean this up. So that I don't have plus minus, I now have plus and negative. So that would be equal to negative 21 plus a negative 3. Either way, both of these will end up giving me negative 24. For our associative property, I think I used red for that one. That's going to be what I'm associating together.
Oh, you would do
Andrew?
negative 3 plus negative 21, and then you just put the parentheses around negative 3 the first time, and then you need a 7 in that, right? Because you need 2.
I don't know. And we have a W there that we didn't use.
We should have used it.
I don't know how to use that.
3 plus negative 21W.
What if I came back up here and I put parentheses around the whole thing and put W? What would my answer turn into?
24. Negative 24W. Oh, I was going to say negative. Wait, can you
Dom?
turn my- Okay, negative 24W.
So if I want to involve that W, now actually, if we want to apply the commutative property even more, what if I put my W on the back side here? Will that, if my W is in the front, or if my W is in the back, does it change? No. So, please, and I'm sorry if you have to erase, I should have warned you to leave a little extra space. We want to show that whether my multiplication's in front or in back, it's gonna do the same thing. I end up with negative 24W. So if I want to change what is associated, Ozzy?
Negative 3W plus negative 21W.
Negative 3W plus negative 21W. I can actually break this up a little bit more. Let's hold on. Hold yourselves. I'm not going to actually use the negative 21W.
What?
I'm going to use a, well, this is dangerous actually.
Wait,
Welcome to the danger zone.
associative
Can't
property.
you without you?
Because with how we had just set that up, there is no associative property to be done. Nothing is associated together yet. So that's the problem.
Oh, we can do negative 3W plus negative 21W plus 7.
Yeah, but I think so. There might be some misunderstanding. Are we trying to make all of these equal to like everything, or are we trying to just make each one equal to each other?
It doesn't tell us which we should.
Yeah, it's not exactly clear. 3 equivalent expressions.
I tried
So
to-
let's not worry about making our associative property match this negative 24w. Let's just make it something totally different on its own. If I want to do that, what if I had negative 3w plus 7w minus 21w?
Wait, negative? Was it?
Or, okay, so plus the negative. Plus the
Yeah.
negative. This is just weird to write.
I know.
Oh, you need to put a parentheses around it.
I don't actually need to. You're right, I can to clean it up, but because we're going to show the associative, I'm not this time. So then to change what's associated,
I just have a question. Wouldn't the answer just be all of those numbers and then just take out the w's and then just do times w at the end, or times 3 times w?
yeah. So to show the associative property, we're not drumming. Join band. Negative 3w with my parenthesis out first, plus a 7w
I was right.
plus a negative 21w. Now check, does it do the same thing?
Yeah.
7 plus a negative 21 would give me negative 14w plus a negative 3w gives me negative 17w. Negative 3 plus 7 gives me a positive 4w,
Oh yeah.
then minus 21w.
No.
Or negative 17.
So hold on, let's check. This became,
Negative 17w.
well, so yeah, all combined.
Oh, yeah.
Over here, we get 4w plus negative 21. Do we still get negative 17w?
Yes.
Yeah. Because, guys, addition and subtraction are really essentially the same thing. So as long as you be careful that this negative belongs to the 21. It is not a minus, it's a negative belonging to the 21. All we did, the only operations that we were doing was addition. Even though we added with negatives, the only operations that we were using was addition.
Yeah, but we didn't use those times there though. I mean, use that for
Well, so there's multiplication in between the number and the variable, but we didn't actually have to solve anything. Like we didn't have to do any multiplication. But if I had multiplied all these values, I could still do it the same way. So if instead of addition, you made these multiplication, it would still work. It would still be the same exact thing. And actually multiplication is the easiest operation to use with the associative property. So then for distributive, let's just make our whole own unique one. So distributive, we're going to have to use parentheses. What do we want to start with outside? Acadia, what number or value do you want to start with? There's no wrong answer.
7.
Excuse me, 7, love it, prime, awesome number. 7, then put your parentheses. If you want, throw a multiplication dot here, but you don't need to write it because mathematicians, we are efficient. We don't write things we don't have to. A number right up against parentheses tells you to multiply. So, what do we want to put inside? Colin, got any ideas for what we want to put inside?
I think negative 3.
Sure, works for me. Negative 3.
W.
Let's leave the W alone for a minute. We could have put it there, but I want to make this easy for us to think through. Monis?
Divided by 21.
There is no division up here, actually, to choose from because division won't work here. So if we multiply in here, we won't need to distribute. So in order to need to distribute, now we're going to look at a couple situations where we don't need to distribute, but we can to make life easier. In order to need to apply the distributive property, you want these numbers inside the parentheses to be different types. They need to be non-like terms. What value up here is a different type of value than the 3 or the negative 3? That's still a number, right? The negative 3 is a number. Now it is positive. I'll give you that. Acadia?
W.
The W. So if we have a constant and a variable. Constants are numbers, variables are letters. If we have a constant and a variable, can I add -3 with W? No, we don't know what W is. I can't add if I don't know the value. So we apply the distributive property. You must draw these arrows. Whether you draw them on top or bottom, I don't care. But each arrow, so this is or. Don't do both, top and bottom. Do one or the other. I like the top just because most of the time I then work vertically. So my first arrow, 7 times -3, gives me -20. Actually, I'll write this out for us. So this becomes 7 times -3 plus, because the operation from between them, 7 times W. Each arrow is a multiplication. So I end up with -21 plus 7W. Jeremiah?
I thought you would do like 7, then parentheses, -3 inside. Like the 7 would be outside and then 3 would be inside.
It is to start. But this is saying 7 times the value, -3 plus W. So since we can't add these together, but I need to do this multiplication, I have 7 times the -3 and 7 times the W, because it's 7 times both of these. Does that make sense?
7 times parentheses, or I did 7 times parentheses 3.
Oh, you mean like over here, just how you wrote it? Yeah, I mean, you could have, like an alternative would be like 7
Yeah, that's what I did.
times -3 plus 7 parentheses W. Yeah, that's fine, because you'll still get to this. Yeah, either way. Sorry, misunderstood what you were asking. So let's try this with a few things. And we use this for situations where we just have an unknown value. So we'll get to some of the real situations. We just want to practice the math of what we're doing. So 3 times x plus 2 is a product of 2 factors. Can you off to the side here please write unlike terms? The x and the 2 are unlike because one is constant, one is variable. So down here, what we're missing that I would like you to add in is arrows from the 3 to the x and from the 3 to the 2. So then you can see another example of this right here in the box. If I had a -2 times a -3y plus 5. Now this gets really complicated because now I don't just have a variable. My variable term has a, what comes in front of the variable? Starts with a C. Coefficient. Most of us are going to need that reminder. Please, somewhere, remind yourself, -3 is a coefficient. So fun to spell. Coefficient.
I would fill out spelling and test if we had to.
And what else is a coefficient when we get to our answer?
6.
Use your hand. I want to call on you, but when you just shout it out, it's kind of rude.
It's 6. Where's the
Yeah,
6?
that's
6 is also a coefficient. Any multiplier to a variable is your coefficient. So, when a number is right against a parentheses on either side, whether it's right against your open parentheses or right against your closed parentheses, the first step is always to... Yeah, why do you think there's 3 words?
In the parentheses. Multiply what's in the parentheses. Or brackets. Use the order of operation.
You know, now that I look at this again, I know what I was going for, but the dangerous thing, don't write this down, is if I gave you this, you don't actually have to, like, do this. But, well, actually, you still can call it this. It would just be distribution to 1. So what I want you to write on these lines, what I was going for, is distribute the multiplication. Sorry, I write too big. Yes. Because I'm on the screen, I got to write a little bigger. Hopefully you guys can fit it on the lines, or at least on your page.
Barely. The end wouldn't fit.
So, even if there's only one value in the parentheses, you are distributing just to one value. If I bring in a dozen cookies for my advisory group and one person shows up, I can distribute the cookies to one person, right? So this still holds true that we're going to distribute the multiplication. So show me here with the arrows what these products or these sums become.
Wait, we draw the arrows in the box or in the...
You draw the arrows to connect that you are distributing the multiplication of a to the 2 and the multiplication of a to the,
and
a
then
to
we
the
have
b.
to write that in the
So then what we have is a times 2, the operation from between them, and then a times b. And then to clean this up, should I have my number following my variable?
Nope.
No, it should come in front to clean it up. Now this is still okay, but we want to clean it up, and this just becomes 2a plus ab.
Why
So
does plus have to look so much like a T?
Why does what? That's why we barely ever use the t. We will hardly ever use the t as a variable. Try the other two on your own. If you get ahead, try the got it. If you are struggling, please stick up a hand.
Why don't you shoot the down?
So does your calculator have a W or a B or a V or a C or a K?
Yeah, there's like a
J.
variable.
Let me check.
Yeah, there's like a variable.
It would take you longer to try to use a calculator than it would to just use your knowledge.
It has a T. Calculator has a T. That's A, B, C.
So, on this second one here, Monica, can you walk me through it? It's the first thing you do. Yep, second one.
We need to draw the arrows from 5 to 1 and 5 to 4c.
So we draw our arrows from the 5 to the 1, 5 to the 4c. That really tells me to do.
Then we need to do 5 times 1 plus 5 times in bracket.
Here, I'm going to write this the Jeremiah way that he just asked me about. So 5 times 1, then.
5 times in parentheses 4c.
Yeah, but what operation goes
Plus.
between them? No.
Oh, minus, right.
The minus in this one. So guys, this is where people are going to make mistakes. This minus does not belong to the 4c. It's not a negative 4c. It's minus, so that operation comes over. So this becomes 5 times 1 minus 5 times 4c, which ends up giving me, Sean, what do you got?
5 minus 20c.
5 minus 20c. Then if I know what c is, I plug it in and I can solve. Jeremiah, question?
Being great. Is your military friend give you that?
Yeah, that's for our presentation this afternoon.
What's in that?
Oh.
I have no idea. Showed up at my house locked. I don't know the combo. Could be people. I'm joking. It isn't. It's his gear. It's all of his gear. It's like his flak jackets, his BDUs, like everything that, like, it's all his gear.
Just these like serious or like.
I thought it was a breakout.
No, it is not a giant breakout.
It's a giant.
There are no guns in there. Ozzy, he's a very smart guy. He's done many school presentations. There are no weapons.
Are you sure?
I am certain. The only thing that is even close to that is in his flak jacket, there are clips and they're empty. They don't even have bullets. So, the last one here, Ellie, what's the first thing I do?
The first thing you do is take negative 0.2, which is 2/10.
Yeah,
Yeah, okay, good. And multiply it by 7x.
I agree. But the first thing I do is draw the arrows. Guys, I'm telling you every year when I do this, and I have people that get progressings, and I ask them where their mistakes came from, there's always at least one that says, if I just drawn the arrows. Because when you draw the arrows, that activates your brain. I'm doing 2 multiplications. So then, exactly what Ellie said, I take my negative 2/10 times my 7x. Then, what comes after that, Julian?
You multiply 2/10 by 3/10.
I agree, but what operation has to be between here?
Minus.
A minus. So this is why I do my arrows on top, because then on bottom I show that I bring over my operation. If I was you, I would be drawing this work just like that. So then I have the negative 2/10. So I'm actually going to put my 2/10 in a parentheses to clean it up since it's a negative, times, now this 3/10, is that positive or negative, Julie? Positive, right? This is a minus, not a negative, so my 3/10 is positive. This then becomes, well, what's a negative times a positive? When I have one negative involved, it's a negative, right? What would 2, forget about the decimal, 2 times 7? 14. Bring your decimal back in.
1.4.
1.4. We said it was negative, and we need the x. Since it's negative, if you want to put it in parentheses, you totally can. But since it's at the beginning of the problem, or the beginning of the expression, you don't have to. Then minus, well, what would a negative 2/10 times a positive 3/10? Jeremiah?
Negative 0.6.
Close.
Positive 0.6.
Think about 2/10, 3/10. Forget about your negative right now. We work straight across, right? 6 hundredths. Be careful with that decimal multiplication. You got to think about it in fraction form. So this becomes, but wait, because we had a negative 2/10 and a positive 3/10, now I get minus a negative?
Yes, which is
Ellie?
Which is plus a positive.
Which is plus a positive. So in the end, this comes out to be negative 1.4x plus, sorry, I wrote the wrong thing down. 6 hundredths. Sorry, I had written down 6/10 here. Please make sure that you have 6 hundredths. I made a mistake. It happens. So in final, that's my expression. Any questions so far?
I feel like I did this in 6th grade.
You probably did a little bit of it. All right, so try the got it. Which one has the same, sorry, I gotta move my screen. Which expression shows somewhere different equivalent to this? So the first thing we're gonna do is figure out what this would be when we distribute. So try this on your own for a minute.
I have a question.
Yeah, what's that?
Can I turn the, oh, never mind.
Did you think the fan was on?
No, I thought the 1/5 was 1/2.
Ah, now you could turn it into a decimal. I just don't know that it will actually make things easier. Because think about this. 1/5 of 5. 1/5 of 5.
Oh.
And then 1/5 of 10.
That's easy. But it's a negative 1/5.
The signs is where people will often screw up. Both the operation in the middle and the signs of the values. So, Jeremiah, what becomes the coefficient to m? Yes.
Oh,
Sorry, I should have last named. Yes.
coefficient of m.
Coefficient of m. So to find that, we do the negative 1/5 times the negative 5.
No, I forgot what a coefficient is.
That's why I phrased it that way. So the coefficient's the number that multiplies. So what number's in front of the m when you do
negative
this?
1/5.
But
Wait, no,
we-
5. Negative 5.
Once we put them together, like in our answer, which is,
1
okay, and then a negative times a negative.
is a positive.
So our coefficient is really 1, so we don't really need that. So we could just say m, or we could say 1m. Either way is fine. Plus, Mr. Smith, what's negative 1/5 times 10 turn into?
Plus 2.
Is it a positive 2 or a negative 2?
Positive 2.
Well, we have a negative times a positive.
Oh, it's a negative. It's a negative.
This is actually a which I can clean this up and just make it m minus 2. So in its most clean way to write it, it's just m minus 2. So number 2, boom, good. Number 3, crap. The signs are wrong. They made a sign error here. This is wrong. Now, hold up. Let's think through the first one. Negative 1/5 times 10 would give me negative 2. Negative 1/5 times negative 5m gives me a positive m. All they did, what property was applied here? Commutative property. So our example and number 1 are the same thing, just with the commutative property applied.
I don't get how you.
Because it went from negative 5 plus 10 to 10 plus negative 5, but we don't have to say plus negative. Instead of saying plus negative, we just say minus. So all we did was turn around the addition. The commutative property lets me just change the order. Yeah, so number 1 is also right. So number 1 is right, number 2 is right, number 3 is wrong. All right, let's try this. Got it. Now, think critically about this for a moment. The question asked to us is which expression can be expanded. To expand means there's a distribution or a multiplication to happen that's going to like make it kind of get bigger or blow up in a way. Which of these can be expanded? Ozzy, what do you think?
I think the first one.
The first one? Why do you think the second one can't be?
Because it's subtraction.
This is 5 minus x minus y. This is 5 minus x times negative 5. So this would distribute a multiplication of negative y. This would just subtract y. Guys, can we stop talking?
Yes.
Because I guarantee if I'm writing something and you're talking, you're not getting it written down. So, do you have these written down?
Yeah.
Both. Try to expand the expression that the architect is using. So, we have a deck that an architect wants to expand. Here's an image of our deck. 3.7 meters wide, 4.5 meters long. He's going to make this deck longer to hold more people. We don't know by how much he's going to make it longer. So we just throw some variable term. Now, why do you think we're multiplying these two values? This 3.7 is like how wide the deck is. This 4.5 plus x is going to be the final total length. Andrew?
Because we're trying to find area, we do width times length, and we're trying to find how much more length, so that's why we add also.
This is our area formula. Until we know the extension, I'm just going to stop class every time you guys are off task. Until we know the extension, we won't know the area. Once I know the extension, I can find the area. So this will become, Jaslyn, what do you think? You don't have to know the products, just tell me like what we do, what we multiply together. Sorry, I'm having a hard time hearing you because they're so loud. So when I look at expanding this, what would be the first thing that you do?
I would add in the area.
Yeah, draw the arrows. Each arrow tells us to multiply. So the first thing that gets multiplied is 3.7 times, and I'm going to go ahead and put this in parentheses just so that it's not so many dots with my decimal points, times the 4.5. Then plus, because the operation from between them, that 3.7 times the x. Any questions on how I got there? So to answer A, if you've identified that that's the width of the deck and that this is going to be the final length and that we're calculating the area, then you're good to go. Question?
To actually solve for it, you can, yeah, it's really easy. You can multiply 3.7 and 4.5, 16.65, and then you divide by 3.7.
Why would I divide by 3.7?
Because x is connected to 3.7 by multiplication, and you want to get
But
x.
you don't have an equation.
Oh, I read that.
You don't have an equation. This is an expression. This is an equivalent expression. Even what you just gave me, I agree with this multiplication. What'd you get from that?
16.65.
16.65 plus 3.7x, which actually, that will go down here. So 16.65 plus 3.7x. This equals the area. Do we know what the area is? No. So right now, all we have is a few expressions that all represent the area. We don't know what it equals, so we don't have an equation.
Oh.
So yeah, you're getting confused that right now all we have is an expression. Now, if I get told the area, then I can solve it. Or if I get told the x, I can find out the area. But without knowing one of those, I'm stuck. All right, let's try this one. We are not going to get to 7-2 today. That is becoming ever more evident. So for your birthday party, you plan to buy 2 cupcakes for each guest and 5 additional just as extras. Because, you know, little brother and whatever else, they're going to eat some. Cupcakes cost $2.25 each. We're buying some nice cupcakes. Let X represent the number of guests you can invite to your party. So, check this out. Cost of each cupcake. Number of total cupcakes that we buy. 2 times the number of guests, 5 extra. So, what does each factor represent? So let's list it out. The $2.25 is the cost of each. The X is what? Yeah, people or guests. And the 5 is our extra. And if you want to list it, the 2 is like times the guests. It is just a multiplier. So if I have 2 1/4, that gets doubled. Because remember, we got to draw those arrows. 2 1/4 gets doubled. Andrew?
$4.50.
We have 4.5, and we can throw the 0 on there if we want to be accurate with finance. Plus, so break this up. 5 times 2 gives me 10. 5 quarters gives me another 1.25, so I get 11.25.
Wait. Yeah.
Wait.
So
Where'd 11.25?
That's
the 5 and the 2.25.
That's 5.
So because this becomes, if you want to write out the work, 2.25 times the 2x plus 2.25 times the 5, that gets you 11.25. Now, what if we invite 10 guests? So down below this, write if 10 guests.
You'd be losing a lot of money.
Oh, you're spending money. You're not losing it. You're spending it on your friends.
And this is your birthday?
So if 10 guests Then I would plug in 10 right for the x. What's 4.5 times 10? 45, so we get 45 plus 11.25. We get $56.25.
That's expensive.
Yeah, those are some nice fancy cupcakes though.
I went to the mall. Wait, I went to the band trip and there was like $3.
Yeah. So, try out your 7-1 homework. Your due date's a few days away, so please bring me questions so we can help alleviate those issues as we get into this. If you want to work ahead in Chapter 7, all of the practice assignments are now posted.
Yeah, thank you for doing that.
Actually, almost all of the Chapter 8 assignments are posted now too. Which kind of scares me that you guys might work like really far ahead, but